This is 2016 AP Practice Exam, multiple choice question number 7, first of all. And the question is, which one of these has an infinite limit? And we're looking at the powers of the numerator compared to the powers of the denominator. So in the first one, we have x squared plus 2x over x squared plus the ln of x. And they both have the same degree, which means we would take the coefficients, which are 1 over 1. So this limit is equal to 1. In part B, it would be 3x cubed over x to the fourth. Since the denominator has a larger power than the numerator, that means that this limit is going to 0. Now in C, D, and E, we have different cases for each one of those. The answer has to be one of these because it wasn't A or B. And for this, we're going to use L'Hopital's rule. So this is the new topic that we just looked at, L'Hopital's rule. Since the limit of the numerator was infinity, the limit of the denominator was infinity, we get this indeterminate form, which means we can find the derivative, the limit of the derivative of the numerator and the limit of the derivative of the denominator and compare that. So in this first one, if I take the limit, or excuse me, take the derivative of 3 to the x, it would be ln of 3 times 3 to the x. If I take the derivative of this denominator, that's 3x squared, and I still have this case which I'm not really sure about. I'm still going to get an infinity over infinity, but if I do that again, eventually my denominator is then 6x, and if I do that again, then the denominator is 6. It's just a constant number. Meanwhile, in the numerator, I keep taking the derivative of this using the product rule and also the derivative of 3 to the x. The numerator is still going to have a 3 to the x in it. The denominator is going to have a constant, which tells me that this limit is going to be infinity over a constant, which is just infinity. So C is going to be the correct answer. Letter D, if I did L'Hopital's rule on this one, eventually I'm going to see that the x cubed and x squareds don't matter. They're going to drop off. And the 3e to the x over 2e to the x is just going to give us a limit of 3/2. And for this last one, we're going to get another infinity over infinity. So if I take L'Hopital's rule and take the derivative of the numerator, derivative of the denominator, those are the same, which means that that limit will be a constant. And this is a question number 16 from the same 2016 practice exam. What are the x-coordinates of the points of inflection of f? So here's f prime. I took the derivative of that to get f double prime, set that equal to 0, and I have these two potential places where there could be a point of inflection. Now, a point of inflection occurs not just when the second derivative is equal to 0, it occurs where the second derivative changes signs. So I'm making a number line with f double prime of x, plugged in different values in the 3 different regions. I plugged in a number less than 0 into our second derivative. The value came out equal to 0. Something between 0 and 3, the second derivative was still equal to 0. If I plugged in something greater than 3, the second derivative was positive. So at 0, when x equals 0, the second derivative is 0, but the second derivative doesn't change sign, so it's not a point of inflection. However, at x equals 3, the second derivative is equal to 0. More importantly, the sign changes there, which means that the only point of inflection is when x equals